Hello, welcome to the webinar on how to help your child excel in math in the AI revolution. Thank you for coming to the website. I hope you learn a lot, but more importantly, I hope that we can work together with your family to help your children reach their full math potential. My name is Amos Tarfa, Amos the Math Guy, and I have been teaching mathematics or tutoring for about 20 years. I grew up in Nigeria, and I was blessed to be the head boy, or the senior prefect, they called it, in boarding school. And through those years, I did a lot of math, a lot of science, a lot of advanced mathematics and further math. I came to the US, got my degrees in chemistry, philosophy, and then master's degrees in medical physics and medical health physics. I also completed some of my work in STEM education and physical chemistry at the PhD level. I completed 1 year of the work and then have taken some time back now to establish some schools and help build this math curriculum called Counting to Calculus. I want to share a few slides with you, so I'm going to just go through a few things before I invite you to join me for the longer presentation that goes to the question of the heart behind Counting to Calculus, the why. We go into more details in the second part of this video. But in this part, in the first part of this video, we're just going to talk about what is Counting to Calculus, how can it help your child. We're going to talk about some of the brief overview of what you can expect with Counting to Calculus. Then, when you have a moment, I would encourage you to watch the full video and you can see why we teach the history of math, why we talk about people like Isaac Newton all the time, why we talk about people like James Clerk Maxwell and Michael Faraday, and of course some of the work of Albert Einstein, which is connected to the work of James Clerk Maxwell. Why do we talk about these people? Because we believe that your children are capable of so much more. The current education system puts a limit or a cap on some of what a child can accomplish because of how it's structured. But imagine if you give your child the opportunity to keep moving at the pace of their mastery. How far can your child go? I believe they can go very far. And that's why I want to help every child to go to calculus and beyond, to learn mathematics and to go deep. That is part of the heart behind Counting to Calculus. So let's talk about a few things related to Counting to Calculus. It basically takes students from pre-algebra all the way to calculus 1, 2, 3, differential equations, linear algebra, and more. It comes with a series of workbooks that parents can get, and they can use these workbooks in conjunction with the textbooks that they have. We have geometry that is taught alongside Algebra 1 and Algebra 2 and Pre-Calc. So students are learning Pre-Algebra, Algebra 1, Algebra 2, and Pre-Calc, and they're learning geometry at the same time. See, this strategy of dual math courses is part of the technique that helps students in places like Singapore and Nigeria to do very well in math. We teach math at the highest level. Our goal is to make sure every child gets access to high-quality math education. So we have a picture of what this looks like, whereby we tell parents that we want your children to learn math classically. And what that means is we have a roadmap from pre-K all the way to the university level. We have a roadmap that shows you every step of the way what the child should be learning. However, the child moves at the pace of their mastery, and they learn the history, the ancient history, Middle Ages, early modern history, and modern history of mathematics all the way till today. What are the challenges in mathematics today? Do you know that part of what's happening with the AI revolution, part of the limitations in how the architecture can be built is limited by the mathematics we know? Isn't that interesting? That means they're looking for more math breakthroughs, more physics breakthroughs. And your children might just have the answer as they get a solid math foundation themselves. So, Counting to Calculus starts again with this, the pre-K through 4th grade. We have programs to help students learn about counting and decimals, fractions, ratios, proportions. They move more into a lot of ratios, proportions, and basic pre-algebra in 5th grade. Then they move into Algebra 1, Algebra 2, geometry, and pre-calc in middle school. Yes, 5th to 8th grade is when we finish Algebra 1, Algebra 2, geometry, and pre-calc, so that your child goes into Calculus 1 in 9th grade with confidence. Counting to Calculus ensures that your child is confident in mathematics, in calculus. We want them to lead. We want them to go to MIT and Stanford and Cambridge and Oxford and lead. If that is the direction they want to go in engineering or medicine or mathematics or computer science, we want them to be leaders and not just followers. We want them to be bringing up ideas that people will listen to and say, that makes a lot of sense. That is part of why we talk about the greatest mathematicians and physicists, because we want to raise the next generation of top mathematicians, scientists, engineers, and physicists who also have a strong background in the history and philosophy of science, which is going to be very important. So, what is the problem right now in math education? Well, students are advancing without actually mastering math. These gaps that they have are compounding, and so a missed concept in 5th grade becomes a wall in 9th grade. Students advance by the calendar year, not by mastery. The gap grows invisible sometimes until it gets to a point where we begin to see those gaps. Number 2, there's another problem. In the AI revolution, there are tools that can do a lot of the homework problems for students. So what that means is that students who depend on AI a lot might just be turning in the homework and getting good grades, but they don't know what's going on. They don't know how to do the problems, but they're just doing what they're told they need to do. And sometimes they just use AI to do it for them. That's going to be a problem because it's hiding some of the gaps they have. And then sometimes grades measure the coverage of topics the teacher has covered, not the mastery. And if a student has a B+ in algebra, what does that even mean? What topics is the student struggling with in algebra? We don't even know. We just know they have a B+. This is not going to work. If we want to raise top mathematicians and scientists like Isaac Newton, James Clerk Maxwell, and some of the best the world has ever seen, we need a mastery-based progression approach. That is part of what allowed people like Maxwell to be doing and writing papers at the age of 15 that he was so young that his professor had to help him present it to the public. Your children can accomplish so much more, and that's where we want to help. We want them to keep moving from one level to the next without stopping, without any gaps, because again, they might have something that the world is looking for. So here are the 4 key features. It's one unbroken pathway from pre-algebra to calculus. That's the first core value proposition. We have pre-algebra, algebra 1, algebra 2, pre-calculus, and calculus. Geometry runs alongside all of that using Euclid's geometry. Yes, Euclid, the father of geometry from 300 BC. Yeah, we use his book with our students because we want our students to learn how to think very well and very logically. And so it's a year-round program. After Calculus 1, though, we have Calc 2, Calc 3, and more. So students who actually go through our program comprehensively get the equivalent of a math minor before they graduate high school. That's part of how we roll. And so we have a mastery-gated progression. People move based on mastery. You have to get a certain percent before you move to the next level. And so that's number 1. 80% or more is what we want to see on these topics. Ideally, we want to see 90 to 95%. But if a child has gotten something wrong, we want to go back and find out why were they wrong. That's a question we always ask our students. Why did you get number 7 wrong? Even if you get a 99%, I want to know why you got something wrong so I can fix it so you don't have that happen again. Number 2, we teach the historical context of mathematics. Students will understand who are the people behind the concepts they're learning. When they hear the word logarithms, they're going to know who that is. Oh, that's John Napier, the Scottish mathematician who was an amateur mathematician. Really? Okay, let's talk about that. Number 3, students have the tools of AI that we've built and that we train their parents in. So our program provides training for parents so that parents can build AI agents to better support their children in education. Parents, we have AI trainings year-round. We have some in person in Houston, Atlanta, Georgia, Chicago, Illinois. So reach out to us. We are providing AI training alongside math fluency for parents because we want the parents to come alongside us to help their children flourish. Why is this important? If you look at the top performing countries of the world, Singapore, Taiwan, and so on in math, you realize that parental involvement is key. That is something that is a non-negotiable. Parents can be involved, but they can be involved by supporting the child. But now we're providing them AI support so that they can help their children, create agents to help their children better learn how to do the problems. And then number 4, we are a year-round program. We believe math is critical, math is beautiful, and we need to learn it year-round. So there is no, you have the weekends off here and there, you have the weekends off, and then you have a week here, a week there, July 4th week off. There's breaks, right? But we want children to be doing about 30 to 45 minutes a day, even in the summer. We want kids to learn math year-round because, again, we want them to go far in their journey. So we break math into 4 levels. the ancient world, 2000 BC to 476 AD. The Middle Ages, 476 AD to 1476 AD. Early modern history from 1476 to 1776 AD. And then the current era, which is 1776 to 2026. What you realize is that within these time periods, there are different key elements. In the ancient history, we have the Babylonians, the Egyptians, the Greeks. We have in the Middle Ages, we have algebra in Baghdad, we have Fibonacci sequence, decimal notation, medieval astronomy. We have Copernicus in the early modern history, Galileo, Kepler, Newton, Descartes. So your children are going to understand the story that gave rise to mathematics. So context creates, the students should understand the context that gave rise to the concepts. And the context can help them put what they're learning into a framework that would help them go deeper in their understanding. So math taught in the context of civilizations that discovered those things. That's how we teach our students. Your students get a clear math from pre-algebra to calculus. No gaps, no ceilings. Your child might become a Fields medalist, a Nobel Prize winner. No problem. We want to give your children the best education possible anywhere in the world today. We have the core mathematics strands I mentioned, which is pre-algebra, algebra 1, algebra 2, geometry, pre-calculus, trigonometry, calculus 1, calculus 2, calculus 3, differential equations, linear algebra, data science, statistics, probability, number theory, mathematics of machine learning, and AI. That's all available to your child. So your child can just keep moving. They could be 15 years old and be in Calc 5. No problem at all. And then if they go to MIT, they stand out because they already know some of the concepts that are being taught at MIT or Stanford or Harvard. And then the second strand that students follow again is that geometry piece of area, perimeter, proofs, logical reasoning, and so on and so forth. We want students to score about 80% and above in order to move on to unlock the next level. We have a mastery tracker that can show your child what topics they've mastered and what topics they need to go back to and review. We also have, the other thing that is pretty cool, is we have this intake assessment free that you could take, and it will show us exactly where any gaps exist in pre-algebra. We also have one that examines algebra. We have one that examines elementary school mathematics. So we have an assessment that can tell us exactly what's going on, and then we get your child going and building a solid foundation. So no gaps. We don't just promote your child because of, oh yeah, they're now 15, so they can just move on to this topic. No, they move based on their mastery. We have a platform, we have an AI adaptive platform, but we also have a regular website that you can get videos and resources to support your child. When you're in our program, we have tutors and people to support your children every single step of the way. You can reach out anytime through email, but the meetings happen twice a week in general. Now, we need to keep in mind that in the AI revolution, we need to recognize the limits of AI and the benefits of AI. AI can do a lot of the calculations, but your children need to grow in their thinking abilities to judge what AI has done. AI can solve algebra problems in seconds. It can generate step-by-step solutions. It can check arithmetic instantly, produce correct answers on demand, explain procedures and requests. Please note, there is something called RAG with AI, retrieval augmented, the RAG, retrieval augmented generation. You need to, your children need to understand that a system built with RAG can help them better have solid answers and have less hallucinations. But agentic AI with RAG, your children will be okay. What I mean is this: we will train parents on how to build a system that generates practice problems. We have some of these tools, but we want the parents to have the ones that they can make for their children and tailor the agent to specifically make problems that would be more relevant to your child. So for example, your child loves engines. Let's use an agentic AI system to build them a math curriculum that uses engines as examples as much as possible. So then your child thinks about horsepower. They're thinking about rates and proportions, and they're using references to engines. Your child can get a custom-made textbook for them by tonight. Like, that's what I mean. Like today, in the next hour, what do you want for your child? What support tools do you need? We can help you build those tools. Now, there are certain things that only humans can do. Humans understand the why behind the question, like why is the answer true? We can build intuition across domains. We can judge whether AI output makes sense. We can transfer reasoning to new problems, and we can apply math to real-world decisions. Children need to grow in their judgment ability in the AI revolution. So counted calculus builds that human mathematical judgment that AI cannot replace, and it also emphasizes that people understand the limits and benefits of AI. We teach all of that in counted calculus. Counting the calculus is for any student at any level with any goal. Here's what I mean. Those who are struggling, who hate math, we can help them close the gaps, build their confidence within a week, and they can start flying. I had a student in around the mountain region of the US that I started working with, and we're able to find his gaps and start fixing it. And the mom said, wow, something happened. He's like getting confident. Yes, we want the students to find any gaps, fix the gaps, and they go from struggling student and they start moving towards becoming very good in math. The next type of student is those who might be average students. They're getting B's. They're doing okay. We can begin to show them the beauty in math with the history and philosophy and applications of math. And now they want more. Tell me more, because I want to be better. And the third category is if you're the best in your country in math, we can take you to another level, right? Because think about it. Newton invented the calculus around the age of 25. Like, if you can invent the calculus, a field of mathematics, co-invented, there's another person involved. Just think about the impact he's made, right? What if your child has some of the abilities that could invent new branches or break down the current branches or connect branches of mathematics? Your child might have a lot more to offer, but the education system is not giving them a chance. So that's what we want to do with Counting the Calculus. We want to help middle school, high school students and support elementary school parents to help their children reach the highest levels of mathematics and science. A word of encouragement to elementary school parents. There's something called Singapore Math. We encourage parents to use Singapore Math. They have something called the concrete, pictorial, and abstract. Your children need to learn starting with things that are concrete, and then maybe get some pictures, and then they start thinking of the symbolic notation and the abstract. So, where do we go from here? We have students and testimonials that people have shared. People have been encouraged. Some of my students have shared some of, hey, thank you for doing this, thank you for doing that. And so we have some of those resources that we can pass on to families. We have a website where you can go and get information. If you're interested in seeing some of these testimonials, right on our Teachable page. One of my students, Reed, says, they asked him why did he pick electrical engineering, and he said, my decision was nourished by Mr. Amos's teaching, and it was nourished by your teaching and mindset about using math to better the world. So he passed his fundamentals of engineering exam, doing very well. Another student says he will break everything down for you, so listen to this instructor. Those are some of the words that you will see from students. Next, we have my credentials on the PowerPoint slide, which I can share with families, and you can see the second half of the video that goes into more detail. The small group tutoring option is $300 a month, and parents can cancel at any time. There's no contracts, no any level. You can come in from 5th to 12th grade. We're accepting students in the 5th to 12th grade category, and then we're supporting families in the pre-K to 4th grade while they get their children ready to enter our program in 5th grade. So you get 8 live small group sessions per month. You get the full Counting the Calculus platform, daily practice assignments, weekly parent progress, mastery gated advancement, diagnostic placement that is included. We have a special right now for those who sign up by April 1st. They get to start at $200 a month. For 1 year, they get a special. Basically, they get to save $1,200 if they sign up by April 1st, and then by May 1st, it'll be $208, and until about August 1st, the prices go back to $300 a month. Email Amos today if you're interested. Complete the intake form, complete the diagnostic, join the first session, and then start learning, start growing, start flourishing. Every topic is a step towards that goal. We want students to master mathematics from counting to calculus. We believe every child can reach calculus. So this is not just for those who are gifted. We believe that, again, everyone can reach calculus, not because they're gifted, but because we teach them right and show them the step-by-step approach of going from counting to calculus. If you want to see a roadmap of the curriculum, you can check out the slides that we have. At the end of the slides, we show you the topic-by-topic progression all the way to calculus. Thank you so much for watching this video. I do have the next segment, which is about 20 minutes, that goes into the heart behind counting the calculus. If you want to get a deeper perspective, reach out to us. If you have any questions, book a call. Let's talk. Let's see how we can help your child. I offer a 15-minute discovery call for free. Just look on the calendar, pick a time, and I look forward to talking with you and inspiring your children to reach their full math potential. Thank you for watching this webinar. Take care and have a blessed day. So how do we teach math classically in the AI revolution? there's this picture I have of like the time periods in history, which I've put together 4 specific time periods. Ancient history from 2024 BC to 476 AD, Middle Ages from 476 AD to 1476 and AD, and then 1476 to 1776, and early modern history, and then modern history from 1776 to 2026. See, in my math curriculum, we go up to wait till today. Like, I want kids to know what's going on today in math research. Like, when you're in a math classroom, it's really sad that many kids don't even know that they can be part of the story of math history. So we're going to talk about these time periods in history. And so my name is Amos. I'm a medical physicist and math and science curriculum writer. As a medical physicist, of course, we use a lot of math. We have to know a lot of math and things like that. Medical physics is beautiful because it has interdisciplinary aspects to it. There's some chemistry, there's some physics, there's some mathematics. And I want to help students learn mathematics go as far as possible. I want them to reach their full potential. That's part of why I offer Saturday webinars. The next one is on March 28th, where we'll be talking about, is there such a thing as a math brain? It's at 10 a.m. Eastern every Saturday, twice a month now, but you could follow us on countingtocalculus.org and learn more about the webinars, countingtocalculus.org. But what I want to do in this episode is I'm going to talk about how to teach math classically in the AI revolution, raising the bar through history, rigor, and the trivium and quadrivium. Raising the bar through history, rigor, and the trivium and quadrivium. So, how do we teach math classically? If you want my slides, reach out to me and I'll get to you the slides. So, we have a crisis in math education. It's not foreign to say at this point. We have places where children are not fluent or proficient in math, large numbers of students. It's very, very concerning, right? But for me, the problem is the fact that math is actually very gettable, I call it. It's gettable. It's beautiful, and yet so many children don't do well in math. Why? Why do children not do well in math? Well, there's a few reasons I think we don't take into account, and I'll discuss it. I've thought about math education since 1996. You're going to wonder, but Amos, you're not even that old. Well, here's the thing. When I was in 3rd grade, back in around 1996, I was doing math problems and creating math problems for my classmates to help them learn how to do math. I was writing out examples. I was trying to explain. So I've always loved math. Now, I wasn't a prodigy that found it all easy all the time. There were times where I struggled. When I encountered certain types of equations, I struggled. My brother helped me get through it, and the rest is history. So it's important that we note that math, like the question of why kids struggle in math literally is part of what runs through my mind all the time. And I'll tell you a few reasons why. So we have made math easy, and in doing so, we've made some of it so easy, like we've done some of the thinking for the children. We've over-scaffolded in some cases, and therefore the students don't learn how to handle struggle or challenges when they get to challenges. We need to find a way to allow children to face some challenges and then help them get to the next level. So modern curricula is partly responsible for this. No struggle for some kids initially, and then they start struggling, and then they think, I'm not a math person. I don't have the math brain, which we're going to talk about a lot more in our webinar. But students need to learn math judgment. Students need to learn how to think for themselves. They need to build that muscle, which leads me to one of the first things I'm going to say that's going to come as a shock to many people. I think we need to make calculus 2 and 3 required. Well, not required, but we're going to make calculus 1 required by law. That's my first recommendation. Calculus, statistics, linear algebra, discrete mathematics, and data science need to all be required before the end of 12th grade. But if you wanted to really know what Amos is thinking, I'm going to add Calc 2, Calc 3, and differential equations to the list. Amos, why are you doing this to K-12 students? Like, why are you raising the bar? That's painful, Amos. Here's why. Because it might be our only hope to get them exercising their mental faculties. If we don't raise the bar, like raising the bar is part of the only answer right now. Like, just think about a student who gets their homework, right? Misuses AI. I said misuses because some of that work, they were supposed to do it by hand, but they went and used AI to do it. And now they have an answer, but AI made their work so easy for them, and they turned it in, and they move on with their lives, and they might have an A, and so the teacher is happy, the student seems happy, and the parent is happy. Everybody seems happy, except there's one problem. Their mental faculty was not exercised. But if we raise the bar, now they have to put in some effort. Parents and educators, I think we have a problem. Before AI came, I used to talk about, or before I was aware of some of the AI tools, please don't, I hope nobody thinks that I'm saying AI doesn't have some applications for research and so on and so forth. There are places where AI is useful. Don't get me wrong. Now, for most kids, elementary school students, middle school students, even a lot of high school students, they're not ready to use some of these tools. They've not sharpened their mental faculties. They've not learned philosophy. They've not learned ethics. They've not learned to reason clearly. They've not learned to read great books of Western civilization. They've not wrestled with the great ideas. The mind needs to be sharpened and ready to be able to take a tool like AI and use it effectively. But let me go back. Before the AI revolution and all of that, do you know I used to talk about this idea I heard called cognitive offloading? When you asked people what is the capital of France, a lot of people, again, well, maybe not that specific question, but they would go quickly and say, let me Google it. They were not thinking for themselves or trying to wrestle with ideas. They had something to help them do the thinking. But even, let me Google it, okay, that wasn't ideal, but that tool of Google is nothing compared to AI. Nothing. Why is this a problem? Because if we don't raise the bar, there will be mental atrophy, so to speak, on massive numbers, whereby students will get to a point where they won't be able to think. And we will have to get some sort of therapy to help them learn to begin to try to think. We have to move fast. And my first recommendation is we have to raise the bar. But the education system is not, maybe that might come as, oh, Amos, why would you want to raise the bar? Take it easy. Because that might be our only hope for getting kids to think. So I've written Counter to Calculus, all these workbooks that I have. I have all these workbooks. And why do I use workbooks instead of just online components? Even though I have a website, I have an app, I have agentic AI tools. I build software tools, but I want paper and pencils and pen. I want people to write down and wrestle with the ideas on paper. And then I want them to have conversations and wrestle with the ideas that way as well. We don't teach math history to students. This is a problem. We have to teach the history of mathematics and science. We have to tell the students why what they're learning even matters. We don't teach the history of math. We're teaching math as disconnected facts. It's not going to work in the AI revolution. We have to help children know, why do logarithms matter? Well, John Napier, why did John Napier do his work? Prime numbers, what is that for? Euclid, why did Euclid do his work? The history is critical. Every lesson, every week. I remember being in college and the textbooks might have a little box that says, here's a little box about the life of Leonard Euler. And I'm like, just that little box? Can you give me a whole lesson? Oh no, we don't have time. We gotta keep moving. Okay, the good news is we don't have to have that mindset anymore. A child who understands the history and is grounded in their understanding of mathematics, history, will do more work, more effectively, more efficiently, and cover 2 to 3 years of material in 1 year because they have a reason. They have a place to put their knowledge in. This is a book that Ramanujan read. Why don't we have our students read it? Why did this book make such an impact on Ramanujan's life? The history of mathematics. Let them read the history of mathematics so that they understand why they're learning what they're learning. There's time to do that. Because some of the computation aspects, especially in high school, that's fine. We can find ways to deal with those. But let's get our children reading more of the history and philosophy of math and science. We need to talk about the trivium, grammar, logic, rhetoric. Children in the grammar phase should be learning facts about different people in the history of mathematics. They should be learning about Leonard Euler was born in 1707, lived till 1783. Imagine students that know the history, the facts in the logic phase. In the grammar phase. They should get a lot of those facts. Who was Euler? Who was Euclid? Learn all the math history, all those facts in elementary school. So my curriculum takes the history of mathematics into those 4 cycles in 1st to 4th grade, 5th to 8th grade, 9th to 12th grade. So they're going to learn ancient history of mathematics in 1st grade, in 5th grade, and in 9th grade. They're going to learn the Middle Ages in 2nd grade, in 6th grade, and in 10th grade. They're going to learn early modern history in 3rd grade, in 7th grade, and 11th grade. And then they're going to learn modern history in 4th grade, 8th grade, and 12th grade. And guess what? When they get to the rhetoric phase, they should be debating things about Gödel's incompleteness theorem. I think it's really critical that we help students to learn how to learn. I think it's going to be important for them to learn about prime numbers and Fermat's last theorem and actually wrestle with the proofs with the teacher. This is going to require changing how we teach all across the board. And I'm available to support teachers in that. On these Saturday webinars that I'm offering, so on Saturdays, I'm offering webinars to support teachers. We have to change how we're teaching if we want our children to even develop their skills and talents to the most of their ability. So we have the trivium, the grammar phase. Singapore Math does a great job of teaching the fluency, but my company, Counting the Calculus, is also going to bring in more resources in that space. So if you want resources that are similar to Singapore Math, Counting the Calculus for the elementary school students is available to you now. Then you get to the logic phase. But in the grammar phase, you'll focus also on, addition, subtraction, multiplication, division, fractions, decimals, ratios, percents, all of that. That's in the grammar phase. And then you're also teaching a lot of the facts as it relates to the history of mathematics. In the logic phase, you're going to do pre-algebra, algebra 1, algebra 2, and pre-calculus as one of the strands, but then you're going to do Euclid's geometry at the same time for 4 years. So everybody who uses Counting the Calculus will use Euclid's geometry over 4 years. Now, maybe some people will do it faster, but the point is, while you're learning pre-algebra, algebra 1, algebra 2, and pre-calc, you should also be doing Euclid's geometry. There's no breaks in Counting the Calculus, by the way, meaning that it's year-round. It shouldn't stop. It should be year-round. So there can be breaks here and there, like two days here. Of course, weekend breaks, but maybe 2 weeks here, 1 week here. But we can't do the summer break anymore if we want our children to be exceptional in mathematics. So in the logic phase, that's what you cover. And then in the rhetoric phase, you focus on calculus 1, 2, 3, differential equations, discrete mathematics, linear algebra. You focus on those things when you get to the rhetoric phase. But you also focus on what is Gödel's incompleteness theorem and what does it show us about the limits of knowledge? Let's wrestle with that. What does Alfred North Whitehead and Bertrand Russell's book, Principia Mathematica, what does that have to do with anything? Okay, let's read Isaac Newton's book. Let's read Leonhard Euler's book, Elements of Algebra. That's what we're doing in that phase. Then we get into the quadrivium aspect of the discussion. So we need the framework of the grammar, logic, and rhetoric. But now we're going to build on top of that the quadrivium. The quadrivium aspect here with arithmetic, geometry, music, and astronomy. The quadrivium aspect, I think, is critical because you're teaching students how to integrate knowledge better in an education system that makes it siloed. The current education system makes it look like a student might learn, go to my math class and then go to my science class and then go to this class. Those things need to be brought back together. We need an integrated approach to teaching. Isaac Newton is the co-inventor of the calculus, but he's also the founder of Newtonian physics. Why do we split Newton into two? It's the same guy. It's the same Newton. We need to rethink what we're doing when it comes to education in 2026 and beyond. Math and the mathematical sciences should be taught together. If a school needs to have 2 teachers teach it, that's fine, but those 2 teachers need to be the students need to see those 2 teachers interacting and begin to realize that these 2 people are on the same team. It's not like, oh, that's my math teacher, that's my science teacher, they don't really talk. No. The integrative nature of the quadrivium, I think, is critical in part of what I'm getting at. But now let me bring it to life here. In that 1st to 12th grade program I described of the grammar, logic, and rhetoric, we also need every one of those years, the students are seeing the interaction between arithmetic and geometry and music and astronomy. Did you know that Leonhard Euler was actually alive at the time of George Frederick Handel? They were both contemporaries. That's crazy. When Handel's Messiah came out in 1741, Leonhard Euler was moving into full swing in mathematics. That's crazy. Now, I don't think they met. If you think otherwise, let me know in the chat. But I think that it's just interesting to think, how cool is it? How cool is it that we can basically show students the connection between all of these things? So we have arithmetic, geometry, music, and astronomy in the quadrivium, right? Johannes Kepler, Galileo Galilei, that's how they would have thought of math. Isaac Newton, Leonard Euler, James Clerk Maxwell. Do you notice? So James Clerk Maxwell died in 1879, by the way. And when James Clerk Maxwell died, Albert Einstein was born in 1879. If you look at the history of mathematics and science after 1879, and especially into the 1900s and beyond, you will notice that there's a different kind of approach to science compared to people who lived before this time period. We need to go back to that type of thinking, because this idea of, you learn the math and science because you need to get a job, that's going to fall short in the AI revolution, because the AI tools are moving way quicker in learning certain basic principles that some students are trying to memorize to pass a test, but the goal of learning to pass a test is completely useless in the AI revolution. You should learn to master, and if you master, you will pass any test. Mastery should be the goal, but mastery that is connected to the bigger picture. Let's begin to land our plane. We need to study the ancient thinkers: Euclid, Archimedes, Pythagoras. We need to study geometry, logic, number theory, foundations of proof. We need to talk about Al-Khwarizmi, Fibonacci. We need to talk about algorithms and where did that name come from? Newton, Leibniz, Descartes, Euler, calculus and analytical geometry. We need to talk about their work as well. They come in the early modern period. So we had the ancient world with Euclid, Archimedes, Pythagoras, and more. Eratosthenes, Tales of Miletus. Then we have the Middle Ages, Al-Khwarizmi, Fibonacci. Then we have early modern, and there's more people. I'm just giving a few highlights here. Newton, Leibniz, Euler, Descartes. Descartes influenced Newton's work, by the way. The Cartesian plane, our students need to make those connections. And then we need the modern age, Gauss, Alan Turing, some of the names that we know today, Terence Tao, and some of your students. Tell them that they are part of the story. They can make an impact. They need to stop thinking of math as just something I do to pass a class. There are, as we said, the logic phase. They will learn ancient, medieval, Middle Ages, early modern, and modern. And then there's a cycle 2 and a cycle 3. They're going to learn all of these things as they go through their work. There's a lot more that we can discuss. We need to encourage students that no summer breaks, no lower tracks. Every student is headed to calculus, because that's the other problem in American math education. If you told me, so listen to a conversation between a teacher and a student, and I'm sorry, I'm not calling out any teachers on this call. I know you're doing your best. A lot of you are doing your best, but these conversations come up a lot. Excuse me, Mr. Jones, why am I learning this? Well, when you get to calculus, you do it. Okay, child goes to another class. Mr. Jones said that when I get to calculus, I'll use polynomials, but I don't even want to do calculus. Oh, really? Well, then you don't need it. That child then goes back to class. Hello, Mr. Jones, when am I ever going to use this? Oh, when you get to calculus. But I'm not going to do calculus, Mr. Jones. Well, that's a good point. Well, just do it because it's on the state tests. We just took the most beautiful subject. Well, okay, let me take that back, because I know there's musicians and artists that are going to watch this. We take one of the most beautiful subjects ever, and we reduce it down to passing state tests. That's really sad. That's really sad. We need to rethink what we're doing in math education. It's not to pass the state test. It's because it's beautiful. But as human beings, we sometimes wrestle with just doing things because they're beautiful. You need to tell me why I need to do it. So guess what? If I know I'm going to do calculus, then at least you have me to pay attention. So we need students to have continuity from counting to calculus without stopping, and they need to move at the pace of their mastery. These are things that we've built. You can reach out to us at countingthecalculus.org and we'll share that with you. Number 2, we need to make sure they learn how to struggle and work through hard things and get the support as they need the support, but they need to learn to fight through these difficult problems. Scaffolding can be a problem when it's done wrongly, and these are things we'll be discussing in the Teacher Training Institute. Number 3, we need the students to get the right mindset. Some of them say, I'm not a math person. We need to change that mindset. Math without history is a skeleton without a soul, is another way of thinking of it. Students need to learn their fractions and decimals and percents. And if we want, we can connect it to the AI concepts for those who want to go into AI research. Learning about fractions and ratios helps with probability, which helps in probability in machine learning models, right? So there's connections that can be made. And this is a research project I'm doing with one of my friends too. We're going to talk about all the different connections that can be made in pre-algebra connecting to other things. So what should schools do now? Let's land our plane. Number one, we need to anchor every topic to a mathematician. Number two, we need to read one primary document per term. Number three, we need to eliminate summer math gaps. Number four, we need to remove lower tracks completely, give students a chance to work hard and give them the scaffolding as they need it to keep pressing ahead. Everybody needs to do calculus. Number five, we need to name the AI connection every lesson. So we need to name the AI connection every lesson if you are interested in bringing in that perspective. I don't think it's necessary for everybody, but there are some kids who are already thinking about, oh, I want to do something as an AI scientist. Well, show them how it's connected and they might care more. Or, you know what, not just name the AI connection every lesson, name connections to different fields that students might be interested in. If a child is gifted in anatomy and physiology and they know they want to become a surgeon, there's nothing wrong with showing them the connections between mathematics and science and being a surgeon. Let's help children have deep understanding and connections to what they're learning. And then we can use the trivium and the quadrivium to really help students learn well. We want to help 1 billion students to take calculus for fun as part of our goal. Mathematics is beautiful, and it happens to be the backbone of AI, but that's not why we do it. We do it simply because it's beautiful. Thanks for watching this video. I hope it was encouraging to you, and I hope we can begin to help more children to learn mathematics in a robust way in the AI revolution. Take care and have a blessed day.